Let's learn how to set up networking in NixOS. We'll start out with some basics like setting a static IP, then move on to some not so basics like setting up VLAN interfaces, basic routing, and routing with VPNs. Let's get started. First, let's start with the basics, a simple static IP configuration that'll match this diagram. Let's start out with some very basic networking. Let's first of all check our network settings. See, I'm being assigned an IP address on this one interface. This other interface isn't actually connected to anything right now. So let's look at the configuration.nix. If you go through it, really all we have is network manager enabled and our host name and domain. The rest of it's just regular user stuff and a few packages. Now, you'll see here that I've included a network.nix, and that's just for the sake of this video for keeping everything clean and easy to see. So if we look at network.nix, you'll see there's absolutely nothing in there right now. It's just a blank Nix file so that we can start doing our network configuration in here. So currently, because there's no configuration specified, the default is for interfaces that aren't specified to be configured using DHCP. So if you don't set up anything for your network, NixOS will try and run DHCP on all of your interfaces, and in most cases that'll work. But if you want to set a static IP, it's a little bit of typing, but let's go ahead and set up a static configuration. So we're going to go networking equals, and then we're going to go first, when you're setting a static IP, you're going to need to manually specify your gateway and your DNS and all of the normal stuff to be provided by the DHCP server. So let's do that. First thing we got to do, default gateway address equals, in my case, let's send it out at 9.33. And that's a string, so we got to put it in quotes. And then interface equals, and that was ENS 18, I believe. Okay, so now we've got our default gateway set. We can set our named servers. And this is a list. You can specify as many things as you want here by putting each one of them in quotes and a space between them. And another thing you might want to specify is your domain. And we did specify that in the main config, but we'll put it here again. And your search. This is basically just so you can type in a shortcut, like instead of typing the fully qualified domain name when you're looking up a host, you can just type the very first part. And that'll be the same as our domain. This one's not required at all, but it's nice to have. And then interface, and actually, my mistake, that needs to be a list because you can specify multiple search domains. So we're going to put that in square brackets as well. And interfaces, and this is where we actually assign addresses to our network interfaces. So another one of those. So ENS 18 was the one we were going to reassign. IPv4.address equals, here we're going to put address equals, and I'm going to assign it the same thing that DHCP had assigned it, which I believe is that. We'll find out soon. And prefix length. This is your subnet mask represented in like the slash notation like normally you'd see after the address, but so in my case it's a /28. That's backwards, so it's this way. There we go. So now we'll save that. And invariably there is definitely a typo. Well, let's see if we can find the typo or typos. Oh, addresses is one, and this actually is just an integer, so it shouldn't be in quotes. This time for sure. And there we go. We still have the same IP address assigned, the same subnet. Our internet should still be working. Yep. Let's get started with VLANs. First, we're going to add another host. Then we're going to add a switch. Then we'll link the two hosts to the switch. And we'll connect those two hosts to each other using two different VLANs, which will appear in the operating system as two virtual Ethernet interfaces. Let's get started setting up our VLANs. First thing we need to do is define the VLAN interfaces. And to do that, we'll go under our networking section and we'll put VLANs equals and then we specify a VLAN interface. This name is arbitrary and you can call it whatever you like. Usually you would name it the same as the VLAN ID you're using, but it really doesn't matter. There's characters you can't use, but you can otherwise call it whatever you want. Like you could call it poop if you wanted, but we're going to call it VLAN 2. And in VLAN 2, we have to define what the VLAN ID is. This will be the VLAN tag that is being used. In our case, we'll use VLAN 2 here. And the parent interface, which on this one is ENS19. Okay, and let's set up two VLANs just for fun. And so it matches the lovely network diagram from earlier. So there we go. Now we just need to do a NixOS rebuild switch, and that'll create our VLAN interfaces. They won't be provisioned to do anything other than simply exist, and they'll be viewing traffic on that tag. So if we do IPA, you can see we have our two VLAN interfaces, VLAN 3 and VLAN 2, and this references the parent interface, which is ENS19 in this case. So now what we need to do is configure them to actually do something. So to do that, we do the exact same thing we did with our regular interfaces. We just VLAN2.IPv4.addresses equals and then we'll set up the same IP addresses from the network diagram, but 2.1, that's a string. Okay, we'll just copy that. And we'll do VLAN 3, which is going to be 3.1. Okay. Then we'll do a NixOS rebuild switch again. And there we go. They've got their IP addresses configured. And I've already pre-configured the second box in the diagram because it's identical. We don't need to go over it twice. So let's just quickly peek in there. So you've provisioned our interfaces and assigned them IPs. And there we go. They can ping each other. There we go. We have a ping going on each VLAN right now. So both links are active. Now let's take a look at routing. This is the network diagram showing how I've set things up. We're going to take the two VMs we were working with previously and turn them into router 1 and router 2. Behind them, we're going to add two new VMs called client 1 and client 2. These will replace the switch from the previous demonstration. All of these systems are going to be pre-configured with static IP addresses shown here. So here we are logged into the two NixOS boxes that we're turning into routers, as well as the two client machines that are behind them. So first thing we need to do to make a NixOS box a router is really quite simple. We have to enable routing in the kernel. So we're going to go kernel.sysctl equals and then in quotes net.ipv4.conf.all.forwarding equals true. Okay, and we're going to do that on both boxes. So there we go. Now, from inside client 1, we're going to try and ping the outside IP of client or router 1 and see now it's reaching that. Now let's try reaching router 2. So the traffic is passing through router 1 and reaching router 2, and we can see the ICMP requests here, but it's not getting replies. The reason for that is the routers don't know how to reach each other, in a sense. They know where each other's router is, but they don't realize that there's another network behind them. So to deal with that, we've got to add some static routes. And it's going to be basically the same on both of them. So in NixOS, this is how we add a static route. ens18.ipv4.routes equals and for that we're going to put in address equals, and this is where we put in the network or the host that we're assigning the route to, 2.0. So we're adding the route that corresponds to the network over here. And this is the same as here, we're just specifying the size of the subnet. And via, we're telling it where the router that handles that network is. So there we go. We're going to copy this. Now we're going to paste it in over there. We're just going to change it to say that we're pointing to the network that this router is responsible for and telling it to send it via that router. Another rebuild switch, and let's see where my typo is, because I'll have it on both of them. And it's prefix length. This time for sure. Okay, so now let's run TCP dump again here. And we'll take a look for any pings coming through. Now they're going in both directions, passing all the way through and replying. Which also means we should be able to ping this one. There we go. We now have traffic moving all the way across both routers. Let's create a wireguard VPN. First, let's create a wireguard interface on our host, which will create an encrypted tunnel out to the internet and to a VPN provider. After this, all of our network traffic from that host will be encrypted over the VPN before it goes back out to the internet. Then, let's turn that host back into a router, add a client behind it, have all that client's traffic go out via the VPN to the internet. Then, just for fun, let's add back our other router and our other client and have them connect to a separate VPN instance in an entirely different country. So client 1 will connect to the internet via an American VPN, and client 2 will appear to the internet as if it's coming from Switzerland. So let's get started by setting up a wireguard VPN. The first thing you'll need to do is log into your VPN provider and download a wireguard configuration file. It'll look something like this. There might be a little bit more, a little bit less, but all of it's there. And one thing I've done, which you should do as well, is take your private key and put it in a file somewhere. So, see, I've saved mine as private key in my home directory as root. It's not generally a good idea to put your direct keys and other secret things directly into your Nix configuration files, so we'll just put it there, and I'm not going to show you what's in it, but it looks exactly like this, just different random letters and numbers and stuff. So let's go ahead and add this to our Nix configuration. So what I'm going to use is the WireGuard Quick setup, and it's the one I recommend. It's very simple to set up. It just installs the WireGuard as a system service, so it's very easy to start and stop. So we're going to use wgquick.interfaces equals, and then we define our WireGuard interface. This can be pretty much anything. The standard is just WG and then a number. And now we define our interface. So the address, and you'll find that most of these keys pretty much match exactly what you find in your configuration file, with the exception of the case. In NixOS, you generally start with a lowercase and then any additional words would be uppercase. So for instance, public key would start with a lowercase p, but the K in key would still be capitalized. So address equals 10.2.0.2/32. And unlike our configuration up here where we specify the prefix length as a separate variable, in the WireGuard configuration, it's specified just directly like that. And this should actually go in a set of these, because you can specify multiple IP addresses. Typically you would have an IPv4 and an IPv6 address, but we're just going to use IPv4 for this. And then you set the DNS server, which isn't actually required, but most VPN providers will give you a DNS server. Okay, and now we got to set up our private key file. And in my case, that was /root/wg/private.key. And as I mentioned, that's just something you could put that pretty much anywhere. It's generally a good idea to keep it somewhere like your root directory or somewhere where regular users will not have access to it. You can set up a separate directory for all your secrets if you like. There's a lot of ways to manage that. And then peers. Now this is where we specify the VPN endpoint and all that stuff. So public key, and that we'll just copy from here. And allowed IPs. See, unlike in Nix, the standard is first letter lowercase and then uppercase. So this is going to be a list as well, so we're going to put it in square brackets. In our case, we're only specifying one. And this is network notation. It means all IP address. It's telling you to set a route to everything. So this will force all of our network traffic over the VPN. And then we need to add our endpoint, which we'll just copy from here as well. Okay. So as you can see, I've commented out what we did in the previous routing demonstration for now, but I'm going to want to put that back later. So I'm just leaving it there. I'm going to go NixOS, rebuild, switch. Okay, and we can see our wireguard interface is up. So let's check our network address, which is I think that's right. There we go. And this IP address belongs to datapacket.com, which is one of the endpoints apparently that Proton uses for its VPN. Now let's check something else out. We previously set this up as a router. So what if we turn routing back on and re-enable our routes? Well, let's give that a go. There we go. Now this is, not only is it routing the network traffic for this machine, but now that we've enabled routing, it's now also routing all the traffic from client machines behind it through the VPN. And let's just, for fun, just to show you that this isn't actually my IP, we've got another. This is our other router from before, and what I've done is I've connected it to a different VPN endpoint on the same provider. So, and it's still set up the same way as a router. So when we check its IP, they're both routing through the VPN through different endpoints and getting different connections. In this demonstration, I used Proton VPN as my VPN provider. I use them for my email, so it just made sense to use them for the VPN since my package included free VPN with them as well. If you are looking for a VPN provider, they do seem to be just fine. I've used them. I've never had any issues with them. I have an affiliate link down in my description. So if you do want to help the channel out, you can use that link to sign up for a VPN account through Proton VPN, or a mail account if you want Proton Mail as well. I'm not going to go ahead and tell you how important VPN is and spew all those lies that are oh so common in the VPN marketing. VPNs are handy and they are useful, but they're not necessary. The only time I would say a VPN is necessary is if you're using sketchy Wi-Fi a lot, like at hotels or cafes and stuff like that. I would definitely use a VPN then. Or one thing that I really enjoy using it for is simply just switching which country I'm using and then using a browser that is signed out from Google and watching YouTube from other countries, because the ads in other, it doesn't matter where you are, the ads in other countries will seem absolutely bonkers to you and they will be hilarious. Well, that pretty much covers everything I'm going to cover in this video. I'll probably do another video dedicated just to firewalling and stuff like that, because it's a bit too much of a topic to include in this just simple networking video. And if there's enough interest in it, I might also do some more advanced topics like OSPF and things like that. Thanks for watching.